Welcome back to another video. We're going to take a look at the comparison between CATIA V5, Solidworks, and also Fusion regarding thread definition. So we're going to get started with CATIA. I have over here position a thread which was created manually because this is, let's say, the only option available in CATIA V5. Because the feature thread, which is available in CATIA, will only do, let's say, the schematic thread. As you can see over here, if you want to do a design that we afterwards want to go and maybe 3D print, we will have to do that manually since CATIA only has the thread definition, which will be schematic and which will be positioned onto the 2D technical drawing. But there's no actually geometry being created. So if you want to make a working prototype, you will have to model it yourself. And over here we have the thread. So for the case study, I will create a metric 10 with a 1.5 pitch. As you can see over here, we're going to have the values for the major diameter, the maximum and the minimum value. I will get started with this one with Fusion to see how easy we can create that over here. And also the software will automatically resize our elements. So to get started, I will create a new design over here. We just need to define the circle. So in this case, I will just make it 10 since I know I will want this to be metric 10. Afterwards, I will press E for extrude. I will select the profile and I will type in 50 millimeters. Afterwards, I will press S to open the design shortcuts. I will type in over here thread. And we're going to see the thread function appearing over here. So I will select the face. This will automatically identify that this is closer to metric 10. As you can see, the size has been added over here. The designation will be metric 10 with a pitch of 1.5. We also have the tolerance class for this one. And I just have to click on this model. And as you can see, Fusion will automatically resize the element for us. Because we have the radius over here, which is 4.925. This will be the average value between maximum and minimum over here. So these two values divided by 2 will go directly on the value added by Fusion over here. So this is all that you have to do in Fusion. We saw that this takes, let's say, only a few seconds. And let me also show you, for example, if I will create this to be 13 millimeters, afterwards have it extruded 50 millimeters. Again, if I will go for threads, so S for shortcut, type in thread. This will automatically see that the closer value will be 14 in this case. But if I will go and have this overwritten with 10, this will automatically resize the sketch. So this is really important and it saves a lot of time. And afterwards, we just click on model and we have the 3D model ready for rapid prototyping. So this is within Fusion. I will now jump to Solidworks since this is the, let's say, next in user friendliness for thread definition. I will just start a new part so we can see everything from scratch. So I will go again from the top plane. I will create a circle. I will type in 10 millimeters as well. Afterwards, I will have this extruded for 50, not 550. Okay. And now to enable the thread within SolidWorks, we have two possibilities. We also have the cosmetic thread, which will be similar to the CATIA, which will only show up on the 2D drawing when we're going to do the annotations over there. But we also have the possibility to enable thread directly over here. And there's also the third possibility to do this manually using a revolve, a swept cut. Okay, so not revolve, a swept, but we're going to define a helix and we're going to have that cut using a profile. But the best solution in SolidWorks is to use the thread feature, which is available over here. We're going to see that by default, we're going to have this notification. So the thread tool type and size profiles are nominal threads, profiles only. Do not use them for production quality threads. So as you can see, to create production quality threads, modify the nominal profile to meet your design requirements. So this is something that Fusion does automatically and saves a lot of time. And we're going to see exactly how it is within SolidWorks. So for the thread, we can specify the location. So I want this to be on the cylinder. We're going to see how the thread will be generated, but only after we specify the end condition. So over here, I can go by revolutions, blind, or I can go up to selection, which will be the best case because I want everything to be threaded over here. We're going to see it in pink generated, and we're going to have the specification over here. So this will be a metric tab. The size will be metric 10 with a pitch of 1.5. We're going to see the values over here. If you want, we can override the diameters over here, but I will leave it by default to 10. And we also have the threading method. So we can also do a cut, or we can do an extrude. In this case, if I'm going to go with the cut, with that selection, we're going to see that we're going to receive these rebuild errors, unable to cut thread on cylindrical surface, use extrude thread instead. So we have the second method over here, extrude thread, but keep in mind that this will add to our thread. So this will no longer be within the nominal values, let's say the ISO standard. But if I'm going to click OK, we're going to see that SolidWorks will create that thread. One note is that I see is that this takes a lot of time. So Fusion managed to do this in few seconds, even though the other solutions were open. But as you can see, SolidWorks will do that cut, and it takes quite a lot of time to process. And at the same time, it won't automatically resize the cylinder. So that will just increase, let's say, the workload. We see the model has been generated. But now if I will go for the thread, if I'm going to select it, we're going to see the annotation appearing over here. So just like we had those over here within Fusion, if I'm going to edit those, we see the profile over there. Let's say the nominal radius. We're going to have that as well over here within SolidWorks. So this will be that file. We see over here, this is still 10. So we should add a smaller value for that. And we also see the profile that SolidWorks use to do that cutting. So we see the shape, we see the dimensions. So these were automatically generated from the database according to the standard, in this case ISO. But over here, if I will want to change this, we're going to see that this is a read-only value, so I can't just double-click and change that. If I want to override that dimensions, I need to go over here, edit features, and afterwards I will have to override it over here. So type in 9.85, since this will be the mean value. We're gonna see how now that profile will change. So it will be positioned over here. If I'm gonna click OK, we're gonna see how that new profile will be shaped. And we have that thread added. But if I'm gonna go now with the measure tool, and I'm gonna select this, we're gonna see that the diameter hasn't been changed for the initial support of the threaded element. This is still 10 millimeters, as we can see. Therefore, we should go within this sketch and have it change over here to 9.85. And only afterwards we're gonna have the thread, let's say, at the intended values. And we can already see the workload required within SolidWorks. quite a lot more. Also the software, we see that it processes quite slowly. Okay, and we have the thread generated. And now if I will go with the measure tool on the upper part, this will have that that value. So this is the value for the cylinder, but the nominal value should be, as we can see over here, the major diameter maximum minimum values in a metric external thread chart indicate the allowable range for the major diameter of thread. The major diameter is the largest diameter of the thread, measured at the crest or at the highest point of the thread. Therefore, as we can see, this is still not according to the standards. So this takes quite a lot of changes and workarounds just to obtain a standardized profile. So this is why Solidworks doesn't have the upper hand over here. But if you're gonna take a look at CATIA V5, this is let's say even older, and it's not that well suited for threaded profiles. But let's take a look at how we can create this one. There are tons of video on YouTube, but I wanted to create this comparison because this is one of the reasons why I decided to pick up Fusion, since it's so let's say easy to use and simplifies the workflow. I will just enable again the top plane, which will be the X and Y. I will create a new sketch over here. And again, I will start with a radius of 10 over here. Afterwards, I will have this extruded. So as you can see, we have that radius of 10, just like we had it over here. So we see that that's a radius. Over here we had a diameter. So yeah, this is why we're gonna change that to only be, so we can double click on this. Since this is set by default to radius, I will just change it to diameter and only have it to 10, since we want to define a metric 10. So we have that. Afterwards, I'm gonna go with an extrusion. I'm gonna make the base 50 millimeters. And now in order to define that thread, as I said, we have the possibility to use the thread and tap feature over here, but this is just a simplified version. I'm gonna start with this. So we have the lateral face where we're gonna add the thread, which will be this one. We have the limit. I can go all the way, as we can see, this will be the bottom, or I can choose the limiting face to be underneath, so that will be the bottom. And afterwards we have the standard version over here, so the numerical definition. I will go for a metric thick pitch, and as we can see, for metric 10, the support diameter will be 10, and we're gonna have the thread depth. In this case, I'm gonna go with 50. But now we see that the bottom will be at the top, so I will just position it like this. So the bottom will be over here. And yeah, we have the pitch, so we can just click OK. And this is the thread. If I will go and have a drafting of this, on the 2D drawing, it will be marked as a thread using the standard symbol that we also see over here. But this won't allow us to have this exported as a step file, as a STL, and have this manufactured and defined as a working thread. Therefore, I will have this deactivated. I will just keep the initial sketch, so this one, which has that cylinder. And now let's define the helix. So in order to get started with the helix, we need to have a point from where the helix will start. Therefore, I will go over here on the point definition, and on the top surface, I will create a point. So let me just add that again. So on that surface, and afterwards have it positioned over there. So we have the starting point of that helix. If you want, you can change it, but keep in mind that this line over here is just a visual representation of how this model is illustrated. And now if I will go with C 2 points helix, this will be the the hotkey to enable the helix curve definition, which isn't available in part design, but we can find that within generative shape design, or we can also find it within wireframe and surface design directly on the toolbar. And for this, I will specify the starting point. And afterwards, we need to specify the axis. So in this case, will be the z-axis. Afterwards, if I'm going to click on preview, we're going to see how that will start. We're going to have the pitch 1.5. We're going to have the revolutions over here. We can also specify this by height and pitch. Maybe it will be easier in this case. So as we can see, the height will be 50. I'm just going to have this reversed. And we're going to have that helix created on the z-axis with the pitch required. And afterwards, we're going to need to define that profile. So to do that, we're going to go within, let's say, the Z and X plane. I'm going to go over here. We're going to have to model that thread profile. So I can make use of the profile tool to define this. Afterwards, I'm going to make the top part to be mirrored at the bottom. And let's add in some values. So from the bottom point all the way to the upper point, I'm just going to read those values from the thread in Solidworks. So I'm going to close the measure tool. And you're going to see this will be 0, 1, 875. 0, 1, 875. For the following dimension, we're going to have 1.5 at the end. So this should be 1.5. And we also have the length of this, which will be 0.8119. 0.8119. So this will be the profile. Now if you're going to take a look at how this has been positioned over here. So we had the helix going from SolidWorks. It was positioned over here directly with the top points. So we're going to match that in CATIA. Therefore I can move that and I can make that upper point and that one, I can make them coincident. As we can see, since that point was a little bit on the inside and we are not directly over there with the profile, I will just go and change the location of that point. So I will double click on that and let's see, we have that point on a plane. We can also have it defined on a curve, which is that curve, and it should snap directly over there. If I will just add this to be length of 0, as you can see, currently the point is positioned over here, but I want it positioned directly over here on that. And now if we'll go again within the sketch, we have this reposition. So this is important because otherwise the profile will not will have that top area within the cylinder. And now in order to have that defined, within CATIA they decided to name this rib, even though usually rib is a different type of feature. So over here they call that a stiffener. But it's quite weird that this is a stiffener, because in all other CAD solution this looks to be known to be a rib. But I'm going to use this one, since this will be the swept definition. We're going to have the profile, the sketch, afterwards the center curve, and we're going to see how that will be defined. And as we can see, by default the orientation of the helix is not well defined. Even though that sketch and the profile are located on the z-axis, CATIA will want to create a helix like this if you're going to go with the keep angle. But if I'm going to switch to the pulling direction, we're going to type in the z-axis over here, and that should correct the helix orientation. And afterwards, if I'm going to create that, you're going to see that element cannot be cut. There are some tangency problems over here regarding that pitch definition. Let me just close this a little bit, because within the previous feature I had the helix a little bit differently. So this was created using pitch and revolutions. 1.5, I added 32 revolutions, so it will end somewhere over here. I can go with one more over here. We're gonna have a warning, but that should still compute. As you can see, face has small edges. It may lead to errors. But other than that, over here, that rib worked. As we can see, again, we had the profile, which the profile was created over here. Afterwards, those. But even over here, as we can see, the model has this weirdly shaped geometry over here, where some of the section is positioned at the top. Let's just quickly have this change within this sketch. So let me define the new rib. I will change a little bit the helix in order to be similar to that, which worked. So I'm just gonna add 32 revolutions for this. It should be the same pitch because the values are the same. Afterwards, go to rib definition. We're gonna have the profile, we're gonna have the center curve, and we're gonna keep this along the z-axis. We see that this also tries to add another revolution at the top, and maybe that's the reason it doesn't work over here, since it doesn't have a support over there. We could have the possibility to have this offset a little bit, and that should do the trick. So let's take a look at how we can make this. So we have the starting orientation clockwise. I'm just looking if I can add an offset value over here directly. But as we can see, it won't allow us to do that. Therefore, I will just create a new reference plane starting from the top. I will leave 1.5 millimeter over here. I will just have this helix no longer displayed, and I will create a new one. So I'll go over here within the sketch. I will create an axis right over here, and I will create that starting point for the helix, which I'm going to position in this case directly onto the axis, somewhere over here, and have that coincident with this. As you can see, it will jump over there. Let's just have it coincident with the axis. And afterwards, I'm just gonna snap it somewhere over here on the profile. Okay. Now I will hide the initial point. Have that newly generated point over here, which is still not directly on the surface. And we're gonna have this sketch, which I'm gonna copy. I'm gonna hide that one. And within the lateral plane, which should be this one, I'm gonna add that sketch again. And I will have this repositioned. So as you can see, that point is still not where it should be. Okay, now visually it is positioned over there, but if I'm gonna zoom in and out, we're gonna see that there is still a little bit of gap. And I will just position this over here. And let's redefine that helix. So we're gonna have pitch and rotations starting from that. We're gonna add the direction. 32, 1.5 reverse. Afterwards, let's redo this We have the profile, we have the center curve, and now this should work, but we can still have a problem that this may not be connected. And we see it worked, but we still gonna receive a warning. Faces has small edges, it may lead to errors. As we can see, those are merged over here. Yeah, we see that I didn't change the pulling direction for this. So this is the weirdest thread. Just gonna go with pulling direction on z-axis, and that should correct that. Yeah, we still have the warning, but now we have the thread generated. Yeah, so as you can see, this is how you can create threads in CATIA. We see it over here, it's slightly undercut, so maybe the location of this profile, as we can see over here, this is 1.5. Yeah, now I see what's the problem. So this is a distance not for that segment, it's for the whole pitch. Yeah, because that's why it has a 1.5 pitch. So let's just add the 60 value over here for those, and that should auto fix this. So we have this, and I'm gonna add that angle between these two to be 60 degrees. And now we see that this will be a little bit narrower because now this was cut multiple times. So I'm just gonna position this with that edge to be constant. Let me just do that again because my mouse usually double clicks sometimes. And we see that it will just not snap into position with that approach. So I'm just gonna eyeball this. And now if I'm gonna leave the sketch, the cut should look like this. I still see that the geometry over here is splitted, but yeah, the reason why we have that middle edge over here is regarding the sketch. Since within our sketch we had one profile over here and one profile over here, so if over here I'm just gonna add a single line, that will no longer appear splitted on the geometry because that was the problem. Yeah, as we can see now, that will only have one. Okay, so as we can see, this is how you can create threads within CATIA V5, within Solidworks, and also within Fusion. I'm really curious, what is your opinion regarding this? For me, this is one of the reasons why I decided to pick up Fusion several years ago, because I saw how easy it is to create threads. And this is not the only, let's say, advantage of Fusion over CATIA. There are also a lot of negative points for Fusion, where CATIA, let's say, it's a lot better and offers more functionality. For example, the surface environment. Over here is quite limited. Let's say you can only use some of these features. Luckily, there's the freeform, which can compensate, but if you compare this with generative shift design in CATIA, those are, let's say, in different leagues comparing their functionality. Okay, so I will position a similar video over here on the left side. I will add this to the playlist, so the comparison playlist. And I will also add a subscribe button. So let me know in the comment section, how do you approach thread creation? What is your, let's say, preferred software? Okay, so thanks for watching.